The next topic we're going to look at is finding maximum and minimum values of a function using derivatives. Before we do that, I want to do a quick recap on what a derivative is. Let's start off with an example. Let's let y equal to f of x as normal. In this case, we'll let f of x be equal to 5 times x. And what I'll do is plot out a table of values, x and y. And I'll let x equal to 1, 2 and 3 and calculate y. So when x is 0, y is 5 times 0 is 0. 5 times 1 is 5, 5 times 2 is 10, and 5 times 3 is 15. So that's a table of x and y values. And we can plot these out. So here's my x and y axes. So I'll mark out my points 1, 2 and 3 on the x-axis, and the points 5, 10 and 15 on the y-axis are the ones I need. And then I can plot out all of these points I've calculated in my table. There's 0, 0, 1, 5, 2, 10, 3, 15, and I joined them all up. In this case they make a straight line, which is no surprise. Let's look at the slope of this line. So for every 1 I go over on the x-axis, I go up 5 on the y-axis. So we say that the slope here is 5 over 1, or just 5. This line has a slope of 5 because for every 1 I go on the x-axis, I go up 5 on the y-axis. This is a straight line, so I'll get the same value of the slope no matter what 2 points I pick. If I go between 1 and 3 on the x-axis, I go over 2 and I go up 10. So 10 over 2 is still just 5, a slope of 5. In general, the slope of a line would be the rise over the run. That's a definition that's often used for gradients on things like roads. If you had a road that rose 1 meter for every 10 meters you went forward, you'd say that was a rise of 1 in 10. Or 1/10 would be the slope in that case. In general, you take the rise, which is the difference in y values between 2 points, divided by the run, which is the difference in x values. This is the same as the derivative. So if y is 5x, dy dx is equal to 5. And that's the same slope everywhere. So you can pick any 2 points, calculate rise over run, you get a slope of 5, because the derivative is 5 everywhere. Let's take another example. Let's say y is equal to f of x again, or this time f of x is equal to a half x. So the derivative here is going to be a half. But let's plot it out. X and y axes. When x is 0, y is also 0. So we go through the origin there, and we have a slope of a half. So if we pick 2 points, x1 equal to 1 for example, and x2 equal to 2, we can calculate our rise over run. So we'll need y1 and y2 from those. y1 will just be f of x1 and y2 will be f of x2, easily calculated. Our slope is going to be, again, the rise over the run. So that's just y2 minus y1 over x2 minus x1. y1 is f of x1, that's just a half times x1, which is 1. So y1 is a half. y2 is f of x2, which is 2, so it's a half times 2, which is just 1. Pop that into our formula for the slope, and we get 1 minus a half divided by 2 minus 1. So our difference there on the top was a half, and our difference on the bottom, or our run, was 1. So our slope was a half. And if y is a half x, we know that dy dx is a half, so that all works out fine. So on this graph, you have to go over 2, or the run has to be 2 to get a rise of 1. So that's the slope of a half. Let's look at a few lines drawn on a graph here and their slopes. So here, say, is a graph of y equal to x. That is a slope of 1. Here's y is equal to a half x, with a slope of a half. Here's a line with a negative slope. So when I go forward on the x-axis, I go down on the y-axis. So this is with the slope of, let's call it minus 2x. So a slope of minus 2. So a negative slope is a line where you go forward on the x-axis and you go down on the y-axis. Finally, here's a line with 0 slope. Finally, here's a line with 0 slope. Let's call it y equal to 2. On that line, if I go forward on the x-axis, I don't go up or down on the y-axis. And if I differentiate y equal to 2, I get dy dx equal to 0. Just for comparison, here's y is equal to 2 plus x. So this line has the same intercept on the y-axis, where x equal to 0 means that y is equal to 2. But that has the same slope as my plot of y equals x. So those lines should be parallel if I do them properly. So that's the plot of y equal to 2 plus x. Now let's look at an actual curve. Let's say y equal to x squared. Looks roughly like this. What's the slope of that curve? Well, it's not a straight line. So if I want to know the slope, I'll have to look at a particular point. And I will look at a tangent to that point. And I will define the slope of a curve at a particular point to be the slope of the tangent at that point. And that is exactly what the derivative is. So the derivative of y equal to f of x at, say, some point x equal to x1, I might write that down as dy dx at x equal to 1. I say that's the slope of the tangent to the curve at that point. Well, the slope of the tangent is defined exactly the same way as we talked about slope for straight lines. So we have all kinds of techniques like product rule and chain rule and all kinds of formulas for calculating derivatives. But all we're actually doing when we calculate that, what it's doing for us, all these formulas, is telling us what is the slope of the tangent to a curve at a given point. That is the derivative of the function at that point. So for y equal to x squared, dy dx is equal to 2x. So let's say at x equal to 1, the slope is 2 times 1, which is 2. At x equal to 2, the slope is going to be higher. It's 2 times 2 is 4. So you know, as x values are increasing for this function, the slope is increasing. And you can see that on that graph there. One last thing to point out is that at x equal to 0, the slope of that curve is also 0. So if I draw the tangent there, it's a flat line with a slope of 0. You also notice that this is the minimum point of that curve. And this is going to be true in general. If the slope is 0, if you think about it, you must be at a point where a smooth curve will be either at its maximum or at its minimum. So what we're going to do next is use derivatives of functions to find where the slope is 0, and hence find where the function reaches its maximum value or its minimum value. So that's the next video.